Hello there, back again. Welcome to the appendix video to the optimized grouping in educational activities seminar presentation. And here we are gonna take a look at the additional 10 questions we stated at the end of the presentation, which were the following. So why not merge topics in groups to reduce the model? So why is there this intermediate layer between the students and the topic? So what is the reason for the existence of that layer? And this is certainly a useful question because it, as we saw, it adds a lot of decision variables to the problem, which have 3 indices and therefore are just present in a large amount. So why did we do this? It was already part of the modeling process. It allowed us to set topic-specific lower bounds and upper bounds with regards to the number of students within a group working on such topic, and also to set a topic-specific lower bound and upper bound for the occurrences of that topic. So it just allowed us to be more specific, so that the professor might have one topic which is fundamental to the other topics, for example, and then he could say, okay, this topic must at least be presented once, so that the other ones have this basis to build upon, and that's why we decided to do so. But alternative would have been to just couple groups and topics together. What you could do then at least is bound the maximum number of occurrences of a specific topic, but just not offering more groups which have that topic attached to it. So this would also been a possibility, but as you might know, it's always a trade-off between modifiability and the size of the problem in the end. And we decided to make a little bit more of a general problem out of it. Now to the second question, which was, how is the artificial user data for the numerical test generated and distributed? So we did so by writing Java code such that you just use the same seed and the results are reproducible. However, in the beginning, we did so using Excel random functions, and this is what I'm actually about to show you first, because it's just more pleasing to the eye. So what we did is we generated a S times S matrix for this Q, social preferences, and had a 3% probability that somebody hates somebody else. And then in that case, you have a uniformly distributed random variable between -0.5 and -1. And all the other ones are 65. Here's a little bit more, but in the actual code, is 65% of people have friends in this seminar, and those friend groups have sizes between 2 and 4. And this is just randomly chosen. And within these clicks, you have uniform random variables between 1/2 and +1. As you can see, it's I think this picture tells more than my words. And here we have this matrix P, where you have a high likelihood of, I think 75%, we will have a look at it now, that you just have no preference towards the topic. And if you do have a preference, then it's either uniformly distributed from 1/2 to 1 or -1/2 to -1. So you don't vote if you don't really care, or you only vote on those topics where you have a strong opinion about it. So to give you some idea how this works, this is the class numerical tests, and here we generate with the rand function with the next double the random values. And for example, this lambda is just uniformly distributed between 0 and 1, and the rest goes to 1 minus lambda, for example. P is the one that I just told you. And Q is also, as I told you here, with uniform random variables. And you can modify up here the hate probability and the share of people which have friends, and the probability that you hate a topic and the probability that you like a topic. So in 50% of the cases, you don't have a strong opinion regarding the topic. Yeah, so this class manages all of that. And also the random instances regarding H and E are created here. So also sigma, this is sigma, and this is mu j are created here. And just to have some versatility in the instances and really have some different results when running these 100 simulations, because otherwise it wouldn't make sense to run very similar instances. And with H, we have some 50% probability that a certain skill is this hard skill is really necessary within a group. And then we have 3, 4, or 5 at max of this skill in the group, depending on this random variable. And yeah, then some other stuff. This was an afterthought, because there were repeatedly there were instances where you had such bad luck that nobody had the skill, because if you run it 100 times, then at some point there's one configuration where nobody has this hard skill and you cannot build groups and the problem is infeasible. So this was just to catch these cases and force some people to have this skill. Yeah, and the other things, we said group sizes are between 3 and 6, and the minimum occurrences of a certain topic is sometimes 1, and the maximum occurrences is the minimum occurrence plus 2. Yeah, so how that's the way they were created. Not in Excel, but actually in Java. And if you run the numerical tests with the main function up here, then actually you will get the same results as you have the same seed, because the seed is taken from this loop in each of the test naive, test improved. The seed is taken from this I, and this I is always the same when you call this function, and the I is the seed for the next double function. So yeah, the results are repeatable. So next question: how to gather student data without subconsciously influencing the professor's evaluation of their assignments. That was something that Thomas and I discussed about, because we said the professor should be responsible enough to not let himself or herself be influenced by something like this. But if you really want to be on the safe side, you could hand out some code to make it anonymous, and let them vote anonymously, and then run the code with this anonymous mapping, and then tell just this anonymous assignment on your Moodle page or whatever. And then yeah, you could do it like this, but it's cumbersome if you compare it to the option to let them vote in Moodle, because then you can export the voting results directly into Excel and just copy paste it into our into our framework. And yeah, but that's up to the user. So number 4, does showing the optimization problem to the students enable strategic voting? So I I want to remind you about our idea of dilution. This was the main idea to normalize the voting system, that you cannot exaggerate your opinion to get what you want. This would be possible if you wouldn't normalize it, because you could just downvote everybody. You have a slight you don't want to be with by the slightest amount. And however, you can still strategically vote, namely if you via collusion with your friends. Then you say, okay, we all vote for the same topic. If we know the mixed integer program, we vote for the same topics to make it more likely that our topic preferences won't divide us despite our social preferences. This could be done, and this is a risk when showing the optimization problem to the participants, that they use it. So this is this was the fourth grade. And the fifth, which hardware and software got utilized for numerical tests? This was actually this hardware. So we use Grobi Solver version 10.0 on a Windows 64-bit computer with a AMD Ryzen 5 5600X hexa-core processor. It had 12 logical processors, so we could Grobi automatically parallelizes the computations, and it really made use of these threads. And it was coded in Java on Eclipse Editor in the most recent version with the most recent JDK distribution. Number 6. What are appropriate choices for the parameters sigma j and mu j? And this is actually a very good question, because as I said, these terms don't have a real interpretation, this term, and they also don't have really trivial bounds which you can use. Here, you know, this term is between 0 and 1. This term is between 0 and 1. And here you really can't tell. So there is, at least to our knowledge, no better solution than using the multi-model for a few combinations and then figuring it out. So in some iterative process, but this can be made faster when using the frontier function, because the frontier function optimizes both objectives, and the absolute value between those two functions isn't important. So it's only about a ratio between those values. So you could run the frontier and then look at the results of the frontier. I might just show it to you. Might be more easy. So if you have, for example, the frontier solutions, and you have the pref-val, and you have the average, you have the preference value and the skill value. Then you can, for the blended approach, you can orientate yourself on the values you see when running this frontier algorithm, and are your expectations for the gaps or for the diversity met, and if not, you might increase regarding this specific skill the sigma j or the mu j. So this frontier can help you because it eliminates this problem of weighting these two functions or choosing tolerances, because it tries out so many variations, but it won't take it away from you to really know how to choose sigma j and mu j. But we have some suggestions, namely in the this file, where it turned out that just as a rough estimate, those values seem to work quite fine, but that's again something that's not trivially clear from the get-go how to choose them. That this is something you should figure out a little bit and play around with. And I think it's even easier if you don't if you choose a little bit less skills, but that's up to you. Yeah. So now to the next question, which is which problems were there to overcome throughout modeling and testing? And there were actually multiple problems, but the most the ones that cost the most time were to generate these random instances without catching 1 or 2 out of 100 which weren't feasible. I already told you this a few minutes ago. When you just underestimate the probability of these edge cases, which might just happen in 1 over 100 cases, and then you have this infeasible problem. So you should write your code such that still the rest is written into your file, and that's actually the case. So yeah, and feasible problems of these random instances were one big stone in our shoe. Yeah, tuning of parameters. Yeah, that's part of the business. So this could be done relatively quickly, but I would say our biggest problem was really the long runtime of the frontier algorithm. I can go back to the pseudocode of it to make the point. I already hinted at the point in the presentation. The problem is that when you enter the second for loop, you already have very, very high restrictions on the value of the objectives, which already have been optimized and now don't want to degrade by no tolerance at all. So in the first you have the tolerance, but in the second one you have 0. You're just asking, hey, is there more possible with the solution I've already found? And these problems have really, really few instances where you find new feasible solutions. It's mostly the case that you find a handful of them in the beginning and then just reduce the dual bound from above. And because this doesn't change anything about the primal solution, we then, as I told in the presentation, shifted gears a little bit by introducing different phases in this solution process. So after 65% of the time limit you gave, Gorobi will use improve start time, and this focuses on improving the primal bound and not reducing the dual bound. After 65% of the time, you really are keen to find a new feasible solution, not prove any optimality or something. We already saw that the results still are very, very okay looking, despite not having the best dual bound in the end. And what we also tried to improve this was use the Gorobi tune tool, .tune, which gives you suggestions how to manipulate Gorobi's behavior to make it more efficient for your specific problem. And we used this tuning tool, and there were really mixed results, and these results did not translate for the larger instances. For the small instances, we had improvements from nothing to 20% in running time, but in the larger instances, it really did not make much of a difference And then we said maybe our optimization is now even this few percent we made were only specific to our instances, and then we just cancel all of it because it just didn't make much of a difference. So this was one of the steps. We also tried to reduce the running time, and another one is that we limited the different parts of the hierarchical approach. Namely, we said the first part, it is a three-step process. If you look at this algorithm for us, here we have two elements. So we go objective, other objective, back to the first one. And the first optimization is really the least important because this is only the bound for the second one. So you don't want to waste too much time at it, and you really want to improve the last optimization you do, or the second to last, but not really the first one. That's why only 1/5 of the time limit is allocated to the first one, and then 40% to the second one. So you always have at least 40% of the time in the last run, in the last step of these three, to really improve the solution you actually are going to plot. And by this, you also guarantee to reach this second solution, because if not, you might have to deal with really a really bad solution if it was not even the third of the three steps. So this was another yeah, we cut our losses, let's say it like this. So some of these multi-instances were really so hard that by doing so we cut our losses. And as we saw, even though we did this, in the end, we saw that there's still a really good approximation, despite many of these multi runs which are needed to approximate a frontier. Many of them hit the time limit, by anyway, all of them more or less snuggle along this line. So that's pretty neat. This was definitely our biggest headache. So how accurate is our students' self-assessments regarding prior experience, EJ in P4? That's very questionable. So how can you really guarantee that the people are realistic with their self-assessments, especially in combination with the fourth point? Because another idea, you might, if you see this problem, you might think, hey, it's a smart idea to really sell myself under the value, because then I get in a stronger group. You might say, well, I can't program, and you give yourself very low votes, and by means of fairness, you get very strong teammates, because they have to balance out your apparent incompetence. So yeah, that's the point. So you really, I think it would be smarter not to tell the students what this optimization problem looks like, because this is very tempting to do. And I think if you think just slightest amount of it, you will get there. So you get this idea after a couple of minutes, I think. So I wouldn't show the optimization problem to the participants, actually. How does the concrete workflow look like when applying the algorithms? So that's really important. And for this, I made this flowchart. So you are the user, and all you have to interact with is start here.java if you are just using it as for application. If you want to test it, you also want to use numerical test.java. And then these two all enter the models, the four, via the wrapper. So the wrapper is more or less the entrance to all the models. And the wrapper calls the models, and the models call Grobi, and Grobi computes the solution. And if the solution is computed, then you you evaluate some metrics as I showed you before in the presentation, and you in part have to convert, because the basic models had this different idea of matching people with people instead of people with groups or people with topics, and therefore these metrics to recalculate metrics which are actually designed for the later models, for the early ones, needed a converter. That's why we need this converter. And the metrics are to compute these metrics I showed you in the end of the presentation. And you, as an end user, again get the results. So as I showed you, you only get in touch with Excel, and all the other stuff with Java you more or less only have to hit run, and that's what I'm about to show you now. So if you're here and you just want to use it, then you go into start here, into the class start here, and look at the main function. You might want to read this, and then you can put the address of the log file where you want the log to be printed here. You can also do this up here and run. So from the Eclipse point of view, you can also do it from the IDE itself, run configurations, and then common, and then you can here query your desired location. But if you want to do it here, you can also do it here. Up here, it will produce some more output. But keep that in mind. And here are the 5 models. You just remove these comments, whatever you want to use, and add your parameters. So where is the input file from Excel? Where's the output file? What is your absolute time limit for the total? What is your duality gap? And if you don't know the duality gap, just leave it at 0.00. And true or false is for that you should definitely read before calling these functions. You should read their documentations. This true function is for the case that you actually fill out the required data to do some of the advanced models, namely age. You fill out age and E with these experience skills and with the hard skills, but you don't want to use them. You just want to evaluate these metrics like diversity and gaps. But you don't. You just provide them and want to see the metrics. And if you don't use them, you should put false there. So depending on the data you provide, you should put true or false there. But it all is in this documentation, so you can always have a read there. And then one presses start, and the Excel file occurs in the location you provided. And as you've seen in the frontier a couple of seconds ago, that's what a frontier would look like. And here you see the priorities, in which order you went through the objectives, the tolerances or weights, depending on what this was. And then you can just mark them, print insert, then a scatter plot, and then you get your frontier. That's how you do it with frontiers. And with the other models, it's even easier. You get only one line. So for example, using the single model, maybe then there's also 100 runs. So if you only provide one instance, you will get one line, and that's it. And your assignment is just via text. So you have group. One group has T1 with students 0, 1, 2, 3. Group has topic 8, etc. So you just have all the values, and you only get one line if you just have one instance. But it's self-explanatory. At least I hope so. Okay. And now I think there was one question left. Which model to use in which case? Yeah. It always depends on what you expect the model to do. If you just expect the basic functionality of providing groups without topics. We have seen that the basic models actually don't perform so badly, so that they are okay. If you want the topics, you can use the single model with the topic assignment. And if you're really interested in this skill distribution and these hard constraints on the hard skills, which every group must have at least or at most at a specific quantity, then use the multi-model. And if you use the multi-model, then it's probably easier to just use the frontier because it runs through all those variants of priorities and weights, and you just get this nice plot, and you can pick a solution. I think it's in that sense user-friendly. On the other hand, you have to maybe tinker around a little bit with the sigma j and the mu j, which you can find up here. Yeah, so depending on the amount of effort you want to put in and the amount of expectations you have, I think all the models provide some value. Also, no model is objectively better or worse than the other, but I think the frontier one, if you bring a little bit of time with you, is really the best one of them all. Okay, so those are our questions and respective answers. I hope you enjoyed this little afterthought or discussion rather, and I could maybe anticipate which questions you might have. Probably not. In that case, please feel free to leave a comment, ask your questions, or leave some constructive criticism. It's really, really appreciated, and we want to keep improving. So on that note, have a good one.